So we are working on radicals, and our very last process is rationalizing the denominator. And I left you with two examples that have addition and subtraction in them. So let's just jump to those two examples, and let's see the process of how to get rid of all square roots in the denominators in these examples. Now we saw some simpler examples here where we just multiplied by exactly what we saw in the denominator. So we're going to use that intuition to start these problems here. If I multiply by the exact denominator, then let's do that here and let's see if that in fact rationalizes the denominator. So let's start with example 3 here, and let's try and multiply it by square root of 7 minus square root of 5. And we know if we do it in the denominator, then we have to do it in the numerator as well. Now I'm going to hold off on the numerator. I'm going to start with my focus in the denominator first, because that's my whole goal here, is to rationalize the denominator. So notice I have a 2 by 2 or binomial. So the process that I'm going to use is to FOIL. First, root 7 times root 7. The roots cancel out, leaving me with 7. Outside, root 7 times a negative root 5 gives me a negative root 35. Inside, negative root 5 times a root 7 gives me a negative root 35. And last, negative root 5 times negative root 5 gives me a positive 5. So if I simplify my denominator, I can combine my constants of 7 and 5 to give me 12, and I can combine my like terms here. So I have a negative 1 root 35 minus 1 root 35, which gives me a negative 2 root 35. So, did I do what I set out to do by eliminating all roots in the denominator? And the answer is no. I got rid of a lot of them, but I actually ended up with an extra one here. So my process is not exactly the same as the process that we saw here when there was no addition or subtraction involved. But the process is very similar. Notice if I wanted to get rid of these, all I would need to do is to make one of them an opposite sign so they would cancel out. So instead of multiplying by the exact same operation, I'm going to multiply it by the opposite operation, meaning I'm going to multiply it by the conjugate. And that is the process that we're going to use. So I introduced that vocabulary word conjugate when we were factoring difference of squares. Conjugates are exactly the same binomial terms, except with opposite signs in the middle. And the reason that they have a special vocabulary word is because things cancel. So let's redo this multiplication in the denominator, and let's show how that does in fact eliminate all of the roots in the denominator. So starting over here. So let's start this FOIL process over. So first, root 7 times root 7 gives me 7 on the inside because the roots cancel out. Outside, root 7 times positive root 5 gives me a positive root 35. Inside, negative root 5 times a root 7 gives me a negative root 35. And last, negative times positive gives me negative, and root 5 times root 5 cancels to give me just the 5 on the inside. So now if I look in the denominator, I have a positive root 35 and a negative root 35, which cancels out. So all I have left is 7 minus 5, which gives me a 2. So we have rationalized the denominator. We have gotten rid of all roots in the denominator. So again, whenever there's an addition or subtraction in the problem, your job is to multiply it by the conjugate or the same binomial with opposite signs. Now, I'm not done in this problem because I haven't looked at the numerator yet. Now, typically, our steps would be to distribute this 4 through, but actually, in this problem, it's a little bit less work to leave it as is. And I'll explain that once we get down here to the bottom step. So I'm just going to copy what I have down from step to step. Now, it's best in this problem to leave it as is, because if I look, I have it in multiplication form where I can reduce my 4 and my 2. 4 divided by 2 gives me 2, and 2 divided by 2 gives me 1. So all I have left to do in this problem, I'm going to rewrite it, is 2 times my square root of 7 plus square root of 5, and that is technically over 1. But we know we don't ever leave it in that form because that's not simplest form. So all we have left to do here is now I can distribute the 2. So my final answer is 2 root 7 plus 2 root 5. And I know that I cannot combine them because my square roots do not match. So we see the process is to multiply by the conjugate and then simplify using any techniques that we've learned up until this point. So in example 4, your instructions are the same. Rationalize the denominator, but you want to simplify it as far as possible. So at this time, I suggest that you pause the video and work this guy on your own. Okay, so rationalizing the denominator, I see that I have a subtraction involved. So the technique that I'm going to use is to multiply by the conjugate, the exact same binomial that I see, but with opposite operations. This one is subtraction, this one is addition. Now if I do it in the denominator, that means I need to do it in the numerator as well. Let's start with our focus in the denominator to confirm that we actually have rationalized the denominator in hopes that we expected to. So first, 2 root 3 times 2 root 3. Remember, you multiply the outside of the roots. 2 times 2 gives me 4, and you multiply the roots themselves. Root 3 times root 3, the roots cancel out, which just gives you 3. Outside of my FOIL process, 2 root 3 times root 6 gives me 2. My root 3 and my root 6 together gives me root 18. Inside, negative root 6 times 2 root 3, negative 2, and again, root 3 and root 6 together gives me a root 18. Last, positive times negative gives me negative, and root 6 times root 6 cancels to just give me a 6. So we notice that this 2 root 18 cancels out. That's the whole purpose of using conjugates in the first place. And here I have 4 times 3, which gives me 12, and 12 minus 6, which gives me 6. So I have, in fact, rationalized the denominator. Now let's see what happens with the numerator. I do have a 2 by 2, or binomial times binomial, so I have to do the same process of foiling. First, 1 times 2 root 3 gives me 2 root 3. Outside, 1 times root 6 gives me a root 6. Inside, a negative 2 root 3 times root 2 gives me a negative 2 root 6. And last, a negative root 2 times root 6 gives me a negative root 12. I want to simplify this as far as possible. So I have like terms in the middle, which I can combine. This is a 1 root 6 minus 2 root 6, which gives me a negative 1 root 6. But most of the time we don't write a 1 in front, so I will eliminate it there. I have this 2 root 3 in front, so let me just copy it down. But if I look at this root 12 here, I can actually simplify it by using a good pi, bad pi method. So I'm going to do that off to the side. Square root 12 breaks down into square root 4, square root 3, where root 4 breaks down into 2, so I have a 2 root 3. So since this is negative here, I will copy it down here as a negative 2 root 3. So now when I go to simplify my numerator, I have like terms but even better than that, they're opposite signs. So my 2 root 3 and my negative 2 root 3 cancels. So my final answer in this problem is a negative root 6 over root 6. So not only does this problem rationalize, but it simplifies to something quite nice. Now that's not always the case, but I picked this example just to prove to you that even though you think you might be done, you can actually simplify it farther than what you may expect in the first place. So I have my final answer here, and I have now shown you how to rationalize any type of fraction, a simple fraction like we saw on the last video, or more complicated fractions with addition or subtraction in it in this video. And again, with addition and subtraction, the trick is to multiply by the conjugate, the opposite sign, so things cancel out. So we have officially covered any type of example that we will see that contains radicals or roots. So this summarizes this set of videos.